Good afternoon, people. Today my topic is on real-time event-based dynamic multi-depot vehicle rerouting. My teammates are Harikrishnakumar, Madhu, myself, and my advisors Dr. Krishnan and Dr. Nannapaneni. Moving on to today's agenda, it's going to be introduction, system architecture, problem formulation, case study example, and summary and future work. The recent technological advancement, such as the Industrial 4.0, cloud computing, and information and communication technologies, has led to various applications in the field of supply chain management. And one such area is going to be the vehicle routing problem, and we have narrowed down the vehicle routing problem with respect to dynamic multi-depot vehicle routing problem for a courier collection agency. The paper presents the development of a system architecture for real-time communication and the route optimization using different combinations of heuristics and meta-heuristics algorithms. Moving on to the system architecture. The system architecture diagram shows that the three different phases or three different departments that constitutes the system architecture for the dynamic multi-depot vehicle routing problem. The first part is going to be the vehicle management center, the VMC. The vehicle management center is a center that performs the following functions, such as directing the vehicle service data, updating the vehicle service request, and assigns the respective routes for the vehicles that is being in the queue. And the second phase is going to be the information network center. The information network center handles the information flow between the system architecture of the DMDVRP, as in it focuses to satisfy the demands of the customers and the publishers. It creates a network between the publishers and the customers, where the customers constantly keep on communicating their service request to the publisher, and the publisher thereby orients it to the vehicle management center. And the interconnecting center is a center which bridges the vehicle management center and the information network center. It communicates with the cloud members in order to deliver advanced vehicle routing solutions to the customers at an earliest possible time. Moving on to the problem formulation. In order to develop the dynamic multi-depot vehicle routing problem, we have formulated the following mathematical formulation model in order to execute this problem. And the main objective of this problem is to minimize the overall distance traveled by all the vehicles across all the depots. And the mathematical equations from 1 to 6 is being shown in the slides, where the equations 2 and 3 basically ensures that each node is visited only by one vehicle, and the equation 4 ensures that the vehicle returns to the depot after the visiting the customer location, thereby enhancing there is continuity in the vehicle routing, and there is no other vehicle has been assigned to that particular customer location. And the equation 5 and 6 ensures that the number of required vehicles is less than the available vehicles. And these are the constraints that has been taken into consideration in order to execute our dynamic multi-depot vehicle routing problem. Moving on to the case study model, the diagram there shows the case study case study model, where we have two depots, and each depot has been assigned with two different vehicles with different heterogeneous capacities. And we have considered around 27 customer requests, out of which 22 falls under the category of static requests and 5 falls under the category of dynamic request. And the data collected for the dynamic service request is based on the two-stage algorithm, where the first stage algorithm obtains a feasible solution, and the input of the first stage is going to be the data fed for the second stage algorithm, and thereby it helps to improve the existing solution. And from the table, we can infer that we have 9 different combinations of the algorithms, where we have got the maximum result by the path cheapest and the guided local search, and provides a much more real optimal solution for the data that we have given. And in the conclusion of the future work provides us with the paper presents a preliminary study with the multiple depots and vehicles with different capacities and real-time service requests, and that is the main idea behind this paper. And we have considered for the future work, we'll be considering the comparing the performance of the rerouting strategies of the Industry 3.0 and the 4.0 technologies. And we'll also consider multiple decentralized decision-making agents in order to avoid single point failures in our future work. Thank you.